In this video, we're continuing to work our way down through history as I work through that big stack of original IBM PCs that I found at eWaste. This, like all the other ones I found in that big stack, are unfortunately missing the cover, but there's a lot of goodness going on in here. What will we find? What will we be able to repair? Will any of this work? Well, only time will tell. It's coming up right now on the Retro Hack Shack. Hey everybody, welcome back to the channel. My name's Aaron, and yeah, last time in the last video, in case you missed it, we fixed up that 5150 motherboard, and it's been a little while since my last video, so thank you all for your patience, and thank you also for your well wishes. I'm making progress on the journey with my eye surgeries, and that's why it's been a little while since I've been able to make a video and put it out on the channel. But what would really help is if you go ahead and click the like button. Don't always ask for that kind of stuff on the channel because it's annoying. Let's talk today about this 5160. Again, this is the PCXT, the second PC that IBM released after the original PC, the 5150. And yeah, this is in not great shape. I'm starting to see why someone decided that maybe these weren't worth the trouble and ended up taking them to eWaste because, yeah, they're already missing the top, and, you know, who knows, you know, what we'll find as we dig in here. But hopefully this will be a quick video and maybe we can just get this thing up and running and it just works. But I will tell you one thing, it does need a good cleaning. Let's go ahead and take a closer look and see what we can see inside this thing, and then we'll take it apart and see what we can get working again. So this is a very standard issue 5160 for the time. It's got one floppy drive here on front, full height floppy drive, and a full height drive cover here on the front. But as we can see, as we get a little bit closer here, it's got actually a half height drive back here in back. Oh, and we can see right away the first problem. Well, not problem, but we're not going to be able to get this drive working even if we were lucky. These things only work about 20% of the time, at least in my experience. And, you know, because they're old and they just didn't hold up very well. None of the spinning rust discs do, but these are especially prone to errors. But in this case, somebody either at a eWaste facility or the original owners or whoever had it before they brought it to eWaste went ahead and drilled a hole into the disk drive itself to prevent people from reading what was on there. Was this some sort of national secrets that needed to be protected? Was there sensitive information on it that would be valuable to anybody from 40 years ago? The answer is no, but somebody in their infinite wisdom decided, hey, I'm just going to drill this thing out, or maybe it was part of like a school, you know, system, and they just have standard practice is to drill holes in the hard drives. I don't know, but I really wish they hadn't done that. Maybe this would have worked. Maybe it wouldn't have. I can see down here on the label that this was a 30 megabyte hard drive. It is an ST238 hard drive, Seagate hard drive. And yeah, it's just unfortunate that we are not going to be able to get this thing working at all. But I will save the front cover here because this front cover could be useful where we could, you know, either Velcro this on or whatever onto the front to preserve the look and then run a cable from the LED, the activity LED on this front panel back through to like an XT to IDE card or something like that, and kind of still give it that same look. Could even put a speaker in here to make hard drive noises. All right, let's take a look at these one at a time. This is an original IBM floppy controller. IBM cards of this time put a stamp with the part number. It's very typical part number. It usually starts with a 6 or something, and they'll put that right on the card, but they won't have any other markings anywhere else. The floppy drive cable plugs in, the internal one plugs in here, and you have a 37 pin connector here for an external floppy, believe it or not. I don't know how many people actually use those. And I showed how to do that on, I believe the first video that you can actually find on my channel is me showing how to make use of this 37-pin connector and hook up a GoTech and do some other fun things with it. So go check that out if you're interested in channel history. All right, now this is the hard drive controller, and this is an Adaptec card. You can see all the Adaptec chips in here, and this came out, or at least based on the dates I see on a couple of the EEPROMs here, this EEPROM and this EEPROM, which is the BIOS, this was a card that came out in 1986, and so this is actually a few years older than the PC itself. So perhaps when somebody got this PC, they either got it with 2 floppy drives or a smaller hard drive and then upgraded it with this card later. And I'm not sure, but given that this is Adaptec, there's a good chance that this particular card is compatible with more than just 1 or 2 drives, as was the case way back in the day. You'd get a card that was very specific to your hard drive, and it may not support other hard drives. All right, now we can take a closer look at that memory card that was in there. It is fully populated with memory, and this is a Diamond Flower MF100 Plus. I think it's a Diamond Flower Plus, and there is a little marking down here if you ever find one of these and you're not sure. It says MF100 down there. Otherwise, very difficult to tell what card this is, as is the case with most of the cards back then. They didn't put manufacturers on a lot of them, so it's kind of hard to tell, but that model number right down there gives it away. Diamond Flower. It's a 384K potentially, if you fill up all the banks like we have here. And so this should bump up the memory, assuming that we have 640K in the computer itself. This should bump it up to 1 meg for us. Now, unfortunately, it does have a Varta battery, and that Varta battery, if the camera will focus here, maybe you can see, has leaked all over these ICs. They all have a nice coating of corrosion on them. So that can mean that the traces going to some of these chips, especially where that corrosion is, those can get corroded away and leave a tiny imperceptible gap next to those chips and can cause problems. So we'll have to see if this is going to work or not. I'm going to cut this battery off right now, and I'll get this soaking in some vinegar to clean up this corrosion, and then a little bit later, we'll take a look and see if this card is working anymore or not. Maybe this is a future repair video. The reason it's called a Plus is because it does have a serial port, 25-pin serial port on the back of the card, but then it has additional headers and a real-time clock. And if I can get this camera to stop jumping around on me, it's got a game port connector up here in the corner. It's got the parallel connector up here. So maybe this thing came with an additional ribbon cable with another connection that would have the parallel port so that you could plug that into the back of the computer. And yeah, clock battery, and just a bunch of jumpers and stuff to configure all of those things for memory addresses and whatnot. But in our case, we'll be very lucky if this is working at all. There we go. Battery just kind of fell off after a little bit of prodding and cutting. So yeah, oh well, throw it in the trash. And last but not least, we have actually an EGA card in here. So this is really nice to see. Again, notice this number right here. See how it's like stamped in there and it starts with a 6? That's a dead giveaway that this is an official IBM part, and this is an IBM EGA card. Hey guys, let's play a quick game. Can you guess which slot was holding that memory card with the Varta battery that leaked all over the place? If you guessed this one, you'd be right. Oh man, look at that thing. I thought this would be like maybe an easy, like clean up the board and get it working, but this is not looking promising. If it ate this much into the ISA slot, yeah, that corrosion could have gone anywhere. Oh well, we'll just keep plugging away at it and see if we can get it working. If you don't want the PCBs you design to look like this, well, then you should order them from a quality manufacturer like PCBWay, the sponsor of this video. PCBWay offers low-cost, high-quality prototype PCBs and a whole lot more. And from now until November 10th, you can enter into their 3D printing design contest. That's right, there's 2 different categories you can submit. You can either create a version of their official mascot Ian, or you can create your very own original character, figurine, or doll. First prize gets up to $500, so submit your 3D printed design today, and I thank PCBWay for sponsoring the Retro Hack Shack. All right, I've got the floppy drive out. All in all, looks like it's in pretty good shape, and it is a Tandon drive, very typical. The belt feels very good. These fabric belts rarely go bad. They're very sturdy. And what else? Oh, here we go. The manufacturer date for this drive is November 27th, 1984, my birthday. But not 1984. I was born in 73, so well before this drive. But that's pretty cool. All right, well, I just took the speaker out, and I believe this original cloth thing doesn't really have to do with the speaker so much as it does the computer as a whole. And if we get the bugs off of here, go on, then yeah, we can see that this computer was manufactured in October of 1984. And this is an Aztec AA12152 power supply, and it does have the IBM part number as well on here, 1501439 for those playing along at home. It's pretty dirty, but it doesn't look terribly bad. I've seen worse. It does have a little bit of corrosion around here, and if this thing was left out with no case on top, you know, that's a little bit to be expected. So it does need a good cleaning as well. But you can see actually the parts that weren't exposed to the elements, how clean and shiny they are. Hopefully you can see that in the camera. So I have medium hopes that this thing can be saved and can actually work again once we take a look inside and make sure there's nothing that's going to blow up on us. All right, well, here's our first chance to look at the board out of the case, and boy, is it ever dirty. I mean, this is the CPU up here, and I can't even, well, I guess I can sort of get through here, but I have to push really, really hard to get in there and see that Intel CPU. And then we've got the BIOS ROMs here, and we have a full complement of memory. So this board does have, I think I spoke incorrectly earlier when I said 640. I think I was thinking of the 5170 there. This board does have 256K of RAM on board, and that means that if we add in that memory slot, we can bump that up to 640. Right? 640K of RAM if we add that memory board, and if we can get that working with all that corrosion. But I think we can stop the corrosion, and hopefully it hasn't hurt the board too much. In fact, if we turn this over, just look at how beautiful the back of the board is because it was facing down. I mean, it's not even dirty. It's got this beautiful dark color under here, you know, and then these really bright, vibrant traces going everywhere. It's just a really beautiful piece of work here on the underside of the board. I'm going to go ahead and have it soak in some vinegar for a while and get rid of the existing corrosion that's on the board. All right, well, these boards over here are drying from the vinegar soak that they had. I've been working on cleaning out the power supply, and it came out pretty well. The dust that was on here when I first blew it out, nothing came out. And that's because the dust had been sitting around long enough in different types of environment, maybe smoky environments, musty environments, that the dust was caked on to the components. And I had to get in there with a brush and really brush around everything really good to get it looking this good. And now it looks great. All right, let's hope nothing blows up. If it does, I should be able to get it on camera, I guess. Here we go. Ooh, heard a pretty loud click there. Not just coming from the switch, but almost sounded like it was coming from a relay or something. Not seeing anything blowing up yet. The hard drive is running, so at least we've got basic power running through this thing. Let's see what kind of voltages we're actually seeing. Okay, this should be the 5-volt rail. Why is this on AC? Okay, let's try that again. 5-volt rail, 5.2, a little high, but that's okay. That's the upper end of what I would want. Let's see if I can get in here and test the 12-volt. Oh no, this is the negative 5-volt rail. The colors are a little bit different on this particular power supply. So there is 5.2. Would that be the power good, I think? Let's see. There's our 12-volt rail, 11.845. That looks good. And this is going to be negative 12. Yep, negative 12 right on the money. So the voltages are looking good except for that 5-volt rail. All right, well, I had this power supply plugged in just for maybe a few minutes while I was doing the testing, maybe 5 minutes at max. I was really starting to smell some nasty burning component smell coming out of this. Some of that could be the dust that was left behind, even though I did blow this out, sweep it out brush it out with a broom. There still could be some dust that was burning off some of those components. The big power resistors in here, this one and this one, were getting super hot. So even though the voltage is measuring fine, I don't really trust this power supply at this point to do testing with. I'm going to use a different power supply just in case. Okay, let's take a look at these boards and see how they came out. Now, as you can hopefully see, this is quite a bit cleaner than it was. So this has been washed and it has been soaking in vinegar. And here is the board, or here's the board. Here is the slot right here that had all that green stuff on it, and it's looking a lot better. If you ever do this type of work with vinegar, you'll notice that the vinegar does tend to take the zinc plating off the pins, so the pins will come out darker as it cleans up that corrosion, but that's just the nature of the game. You can see some bent pins over here on this side of the slot, so like I said, these are pretty hard to fix, so I probably will just mark this unusable at this point and work around it. There's still a tiny bit of green stuff that I can see, but I don't think that's active corrosion. I think that's been neutralized. I could always maybe brush that off with a metal brush or something. But anyway, yeah, that's the outcome of this board. I'm not noticing a whole lot of corrosion on any of the neighboring chips or anything. So hopefully we caught this in time. And the only real damage was to this one slot. Now, in terms of this board, it may look okay at a distance, but looking at it up close through using my phone or a microscope, I can see that there is quite a bit of damage to this board, not just to the traces, but to the actual components. Here's some resistors that it's eaten through some of the legs of those resistors, and they're just dangling. And yeah, without doing a lot of work on this board, again, as I said, could be a future repair video. If you want to see that, let me know down in the comments below. But there's still some green stuff on some of the chips, so I probably put this through another vinegar treatment just to make sure I got it all. But yeah, it's just not looking good, unfortunately, for this board. Perhaps the memory chips are okay, so those could probably be salvaged. All right, well, here's the first test. Now, I did test for shorts as well with the multimeter on all the voltage rails, and there's no shorts as of yet. Got the speaker hooked back up. I've put the EGA card back in. I've got that connected to my RGB to HDMI that I sell on my site. And I've got my USB keyboard connected to the Hidman, also sell on my site. A couple of shameless plugs there. But this will allow us to connect, in case this thing just does come up and run, it'll allow us to at least type in some commands and see what's going on. So I will need to switch the Hidman over to XT mode as soon as it gets power so that this thing will actually work. Without further ado, I think we're ready to power this on and for the first time and see if anything happens at all. Do we have any signs of life? Here we go. Let's see if we get any speaker beeps. Getting a white screen out of the video card. There's nothing going on the system level. No beeps coming out of the speaker. So let me check the settings on the switch. There's a dip switch back here behind the card. You can't see it right now. Let me check those settings because I know that we've probably reduced the total amount of RAM on this board since we had that memory card in there. It's probably set for more memory than we have right now, which should be 256K. So let me go adjust those settings on the dip switches here and reboot it and see what happens. All right, well, I went through those switches. The only one that was set incorrectly was the one for the video card, which was set for a CGA card and not an EGA card. So anyway, I also exercised those switches. They're a little crusty, so I exercised those dip switches back and forth a few times. So let's try it again and see what happens, if anything. Again, we're just getting a blank white screen. Almost looks like I'm booting a Mac here, but I'm getting no beeps and obviously nothing going on the screen. So yeah, that is unfortunate. Looks like it's not going to be any kind of quick fix. Do a little cleanup and get it working. Looks like we're gonna have to do a little bit more than that. Next step, just like I did with the IBM 5150 motherboard, I'm gonna go ahead and reseat all of the chips that are in sockets and put a little bit of deoxit in them all. You know, we've had corrosion on this board, we've had vinegar on this board, we've had water on this board, we've had IPA on this board, and not beer, by the way, that's isopropyl alcohol. You know, after all of that and having this thing sit around for a long time, it could be that there's a bad connection somewhere. So that's an easy thing to do. That's what I'm going to do next. All right, well, I've pulled all the chips that I can and deoxidated, put them back in. I noticed a couple of things as I was doing that. Number one, there is a chip up here that doesn't seem to have been reworked. At least if it was cleaned up really well on the underside of the board. Usually you can tell if someone's been in here messing with it, but this is in a socket. So maybe that was from the factory. I don't know. It's just a logic chip, so I would normally expect that to be soldered right to the board, but it is in a socket. And then there is an empty socket. Oh, whoops, not that one. Over here. There we go. My eyes work sometimes. And this is U48 on the board, and it does not need a socket in this version of the board. This is the 64 to 256 version of the 5160, the lower memory range one, there's another version of this that goes from, I think it's 256 up to 640. That one does need this U48 chip, but this board does not, so it probably never had a chip there. Okay, still getting that white screen. No beeps yet. Now this is a little bit similar to what happened on the 5150, and on that board, we had bad memory. So I believe that RUD's diagnostic will also work on the 5160. So let me go get that, and we'll see if that is able to tell us any more information than we're getting from this white screen. All right, so I went and I found my RUD's diagnostic that I used last time. If you watched that last video where I repaired the 5150, that was really helpful. And they've updated the type of ROM that this BIOS uses, so we need a different chip to put in there. And we don't have to use this adapter anymore either. We can just use a somewhat standard 27C256 EEPROM chip. And so I've programmed one of those up. And U18 here is the chip that we want to remove. So we'll carefully remove that and set it over here on the anti-static foam. And then go ahead and put in the RUD's diagnostic that I loaded onto this chip. And we'll see if that works. RUD's diagnostic, in order for it to test all of the memory, including the first row of memory, which is usually used to boot the system, it needs an MDA or a CGA adapter card, video adapter card, to use the memory on it instead. So it loads into this memory and runs, and then it has access to test all of this memory over here. All right, I've got the RGB.HDMI in CGA mode. Let's see what happens. Do we get any beeps? No beeps even with RUD's diagnostic. That's not good. Well, but it does help us kind of narrow down what's going on. There's either some sort of catastrophic failure on the board, or we've got one of the, basic chips that you need to run the board is failed, like the CPU. CPU could be failed here. So I guess now it's time to pull out the oscilloscope and see what's going on. All right, so I've got my oscilloscope set up over here. I've got the pinout for the Intel 8088 here. And I noticed that as I left this on longer and longer, the CPU was getting warm, and it was kind of in an odd way. It's not just in the middle, but it's like on this side of the chip for some reason. There's no other chips on the board that I can tell that are getting warm, but the CPU is getting warm. So I'm a little suspect at this point of the CPU. There, it's warming up. I've only had it on for less than 60 seconds. Don't go to sleep. Yeah, it is getting quite warm, but before I take it out and just assume that I'm going to replace that with another CPU, let's just take a look at some of the signals and see what we see, so that if we do replace it with another CPU and it's doing the exact same thing, then maybe the CPU wasn't bad after all. Let's go ahead and look at the, let me take this off. This is going to be a little difficult with my eyes. I might use the socket up here because that's a little bit easier for me to get into. So this should be nothing, right? So that's ground, and VCC is going to be up here. Oh yeah, there it goes. That didn't look right to me at first because I was on the wrong pin, but 5 volts is all the way at the top here. I've got this set for 1 volt per division, and if I need to, I'll bring that down to make it a little bit more readable. But yep, 5 volts is good, ground is good. Let's look for the clock, which should be the second pin. It's pin 19 here, is clock. What are we getting there? Nothing, absolutely nothing on the clock. Well, if there's something on the clock, it's not doing a whole lot. So we could just be missing the clock, honestly. Let's take a look at the reset pin, which is over on the other side here. And I don't see, that is low. Let's go ahead and turn this off and on again and see what happens with the reset pin. Okay, nothing. The reset pin is being held low, it appears. We can look at some of these address lines, but I don't think there's anything going to be going on these address lines, because I think the CPU is either bad or it is just stuck. It's either being held in reset or it is just stuck. And I'm looking at some of the address lines, some of the data lines. There's absolutely no activity on this thing at all. Just grab another CPU and stick in here and see what happens. Okay, I just realized we can do something even better. I've said it before on this channel, but whenever you have the chance, if you're going to be doing a blind swap of a CPU or RAM or some other chip like that, and you have something else that you can put that in, a known good working board that you can put the suspected bad component in, that's always better than putting, in this case, it would have been an unknown, a spare CPU into a board that we really don't know the state of at this point, because there could be multiple things going wrong, as I said. But in this case, by using a good board, this is the 5150 that I repaired in the last video. If I swap and put this suspected bad CPU in here, everything else we know is working. So we should be able to tell right away if this CPU is good or bad. And this, I've got to be careful because this is actually going out. Somebody bought this on my eBay store, so I need to get this out to them. And I was going to do that tomorrow, and I'm glad that I thought about this. And I just have to be careful not to break anything else. But anyway, we should at least get some beeps. If this CPU is working, we should get some beeps coming out of the speaker. So let's go ahead and turn it on and see what happens. You'll hear the beep. I know I don't have the screen on, so you'll have to take my, oh, there it is. It's actually booting. I can see the cursor is blinking. Beep. Yep, got a 301 error for the keyboard, and we're into Computer Basics. So this CPU is actually good. All right, so I've been doing a little bit more probing around, and because I didn't see a clock signal on the CPU, I decided to move to the thing that generates that clock signal, which is an 8284A chip. And what that does is it takes in the oscillator, the crystal oscillator clock, essentially, right? That frequency, and then it divides it by a third and gives the 4.77 megahertz signal that is the clock for the system. And if I look at this chip, I'm on pin 2. And if you look over here, I think I'm on pin 2. There we go. So pin 2, this is one side of the oscillator, right? And then we go to pin 3, that's the other side of the oscillator. So I'm seeing the oscillator is working. And this also verifies that if you remember on the 5150, we had a bad trimmer capacitor that I took out and replaced with just a straight up regular capacitor. This validates that the trimmer capacitor is working, because if it wasn't, the one side of this would be bad or weird or not there, right? So I think the trimmer capacitor is working as well. Everything is set for that 8284 chip to work, but it's not outputting the clock signal, the 4.77 megahertz clock signal. So I think that chip is, I'm going to try to replace it, but I've got to find a chip. And that's going to be the next thing I do, is to socket that chip and put a new one in, see if that works. 4 to 6 weeks later. All right. Well, through the magic of editing and time, I am back. It has been quite a while, actually, since the last thing you just saw to now. Well, in the meantime, I've gotten some chips in from online, and then I went ahead and took out the old one, desoldered it, put in a socket, and then put this new chip, probably new old stock, in here. It actually has a 91 date code, so it's newer than the other one we had, but it's not that new in the grand scheme of things. Also, since that time, I've had another eye surgery, and because they found a retina tear, I won't go into all the gory details. I think all the details are on my Patreon page if you're a member there. But back to the problem at hand. This chip, I want to see now if that clock signal looks any different since we changed out the chip. If you remember before, I'm kind of resetting for myself and for you guys. Maybe you just saw this a couple of minutes ago. I'm acting like it's months ago, which it is in reality. But what we would expect to see here are a couple of things. We expect to see, instead of a very low level clock output going on, we expect to see a normal clock output going on the oscilloscope. And if everything else is working, all the memory and stuff, or even if the memory is not quite working, I still have this RUDS diagnostic in here. So I would assume we would at least get some beeps out of the speaker, which I also have connected. Don't have video connected, don't have keyboard connected. We don't need that right now. I just want to see if replacing this chip has made any difference in the amplitude of the clock that's coming out of it, or should be coming out of it. So I'm going to see if I can get on the clock pin over here where the believe this is the right one, where the math coprocessor usually is. So I believe I'm on the clock pin there, and we can go ahead and turn this on and see if we get something different over here. Yeah, so I'm on 5 volts per division here, and let me make sure I'm on the clock pin. I'm still not seeing a clock. Now, is that because before I got everything situated, the clock was halted because something else is going bad? Let's reset this again. Oh, interesting. So it is up to 5 volts now, which is good. It goes up there and then just kind of stays there. All right, well, I've got another board. This is the one I was looking for, and this is a clone of an XT system. This is an XT clone, and it's got the clock chip right over here. This is the one that I would have grabbed if I could have found this board before. It's got no cards in it. It's got this ROM where the pins were all bent, so I took it out, straightened them out, put them back in with a little deoxit. I just want to see if I can get a beep or some sign of life from the clock chip. So I just wanted to have a reference. So this thing doesn't even really need to boot. The memory's probably bad or whatever. I don't have RUDs in here. I just want to see if I can see what this clock should look like on a similar system. Here we go. Oh, heard the speaker come on. I wasn't hearing that on the 5160. Okay, so hopefully you can see this. This is what the clock should look like. I'm getting 5.3 volts peak to peak. You can see I'm on 2 volts per division. So I've got a really good clock signal there, and I'm not getting that on the other clocks. A couple of things come to mind here as I'm thinking about this. I mean, if the clock is connected to the output of that clock chip is connected to some other chips on the board, maybe one of the other chips is bad and it's pulling the clock signal down. So that's a possibility, and it's a good thing I socketed that on the other board, because then I can pull that leg out and see if the clock signal is really good coming out of the chip, but it's getting pulled down by something else. So let me go ahead and do that. Okay, I've pulled that pin out and I'm just touching that with the probe for the multimeter. Nothing else is going to run, but I should at least be able to see the output of the clock coming out of this thing. Let's see if it's low or normal or nothing. The system's on, and I can see the very interesting, it doesn't have the same kind of clock that I would expect, but it's going up to 5 volts, which is what I thought would have happened. And if I go over here to the actual clock line, you can see that that's running about 2 volts. All right, so I went ahead and pulled out the schematic for the 5160, and a couple of things I wanted to check out to see. One is, where does that clock signal go? And what else is connected to this Intel 8284 clock IC that's generating the 4.77 megahertz signal that we were seeing, or not seeing as the case may be, on that pin 8. So if we look over here, there is the pin 8 here has, it's called clock 88. I'll zoom in on this in just a second. But the signal they say is clock 88. It goes up here to the CPU on pin 19. And then it also goes down here. It makes its way down to the 8288 chip for its clock as well. So they both share that 4.77 megahertz that's coming off that pin 8. So I think what's happening is, since I pulled that pin out, that it's just floating, and that's why we're seeing 2-point-something volts. It's just literally floating. That clock pin on the CPU is just floating because it's not being asserted high or low. So that could be normal. So let's zoom in on this 8284 clock chip and see what's going on. All right, so this 8284 here has inputs for the crystal, which is coming in at 14.31 blah 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 megahertz, right? And that gets divided down by a third to output on what they're calling clock 88 here, which is that pin 8. And that's the 4.77 megahertz. It also comes out as the P clock, which is only a 50% divider here. The P clock goes to peripherals like the keyboard, for example. So that's a 50%, so that'd be 7.12 or whatever megahertz, right? Coming out of the P clock. This oscillator goes off to the ISA bus. That is on pin 12, and that just actually, I think that just passes through the crystal clock rate on the oscillator signal here, pin 12. Like I said, I think that goes to the ISA buses. The thing that was interesting to me is that there is some circuitry connected over here to this FC connector on pin 13. And so I wanted to see what that FC pin does. Okay, so this FC pin 13, has a little dash above the C, and I think the C means low, and we can see that this is either frequency or crystal select. When FC is strapped high, clock is generated from the EFI input, and when strapped low, the FC allows the processor clock to be generated by the crystal, which is what we want. We don't want the clock signal to be generated by EFI, we want it to be generated by the crystal. And so we need pin 13 to be low in this particular case. So when we go back to pin 13 here, well, first of all, you can see EFI, which is on pin 14, is not connected on the 5160. So if this is wrong for some reason, it's just not going to do anything. And by the way, that's what we're seeing on the clock right now, is it's stuck high at 5 volts and it's not sending out a clock signal. So this FC pin here needs to be low, and that is going through, it's getting 5 volts through a resistor network, which is a 4.7K resistor there, and then that's being passed on to U22, which is an LS04, which is then connected to this FC connector. Now, LS04 is a hex inverter, so that should just be inverting the signal. When this is 5 volts, this should be going low. So now what I need to do is see what I'm seeing on pin 13 and then go back and see what's being input to LS04, and perhaps this is being held high, which is going to generate a clock signal off of EFI, which is nothing, which is kind of exactly what we're seeing. So let's take a look at the board and see what those signals say, and maybe we can make this make sense. All right, so let's test this theory out and see if we're getting the right signals here out of these chips according to the schematic. So the clock chip is all the way up here by the CPU, and the resistor network chip is down here, this blue one down here, and then U22 is right up here. So these things are not all in the same area. They're kind of spread out a little bit on the board. The first thing I want to do is just verify that we are seeing that this chip, actually U22, is directly connected to pin 13 over here, because if there was some sort of break in the traces or something like that, that could potentially cause this problem too, where we have a floating input, potentially. So why am I not seeing? Oh, there it is. Yeah, I just wasn't pressing down hard enough. Okay, so definitely I am connected to U22 and very little resistance there in that trace, so that's good. So now let's go ahead and turn it on and measure that whole small series that we see going through this chip and see if anything is amiss. All right, so the first thing we should see is 5 volts on pin 16 of this resistor network. Yep, we do. That's good. And then it's going to go through the resistor network and come out on pin 11, which is 9, 10, 11. So yeah, we've got 5 volts there. So it's going through the resistor. We still have 5 volts. And then that is connected to this LS04 U22 on pin 11. 10, 11. Yep, we got 5 volts there. And then this is going to go through the hex inverter and come out on the pin right next to it, pin 10, and we should see low on pin 10. So 8, 9, 10. Oh, yeah. First sign of trouble right here. That should be low, and we're seeing float, like 2 volts or something. So yeah, that definitely could be the problem. And we know that this is connected over here to pin 13. It's right there. Yeah, and that's exactly what we're seeing. So now we're sitting at like, I don't know, 2 volts or something like that, which could be interpreted one way or the other depending on the chip, since it's right in the middle, right? Normally you want a good low signal or a good high signal, meaning either close to 0 volts or close to 5 volts in this case, and we're seeing somewhere in the middle. So maybe if we force this low, that would force it to use the crystal, and we could see at that point at least if this clock chip is actually working. All right, well, I have that the FC pin pulled to ground, so it's definitely low at this point. Let's see if that makes any difference in what we're seeing on the clock pin. No, it doesn't. Come on, what? I thought for sure that was going to be it, and no, it just reads constant 5 volts, no clock on this pin at all. So something else is causing this not to work. What the heck?
Several months later.
Okay, well, it's been a while since we've been looking at this 5160. Not for you watching the video, but for me, I actually took a break on the 5160 and did some other videos. Now I'm coming back to it about 4, 5, 6 months later, something like that. It's been a long time. Anyway, and I'm also testing out a new oscilloscope, and I'll have a video on that coming up soon. So I went back and watched my footage as I'm trying to get back up to speed with where I am with this project. And I discovered one thing, which is that I was trying to pull this FC pin, meaning external frequency generator or crystal pin, low, and I was actually pulling it high because I was tied to the wrong pin over here. I was actually tied to the high pin, so it was just high all the time. So I went ahead and switched that to low, and now we can take a look and see if we're getting any clock signal on the clock pin with that thing tied low. Let's see. Okay, it should be up and going. And, oh, yes, this is hard to see, but I can see a wavy line there. That is good. This was high before. It was just high all the time. Now it's kind of at 2 volts or something, and it's got a little bit, I can see a little bit of a clock. Let me zoom in and see if I can get a frequency on that. Yes, there it is. There's our clock, and I believe it says 4.1, can't make it out. I'll have to tell you in editing. I think it's 4.17 maybe. So that is exactly what we expect. So for some reason, the problem, hopefully the only problem, we don't know yet, but definitely right now the problem is that that FC pin was floating a little bit too high and it should have been tied low. Okay, so I've gone ahead and off camera desoldered the chip that was in here, and boy, are these ground planes annoying on these motherboards. They're multi-layer boards, and getting the ground pin off was very difficult. I ended up just cutting off that particular pin. All the other ones came out clean. I didn't even have to use the hot air method. I mean, they all just came out clean with the desoldering iron, but that ground pin was super, super annoying. But I finally got it out and put it in a socket, and now we've got a new 74 LS04 in here. So what I want to do now is confirm that we are indeed getting a good clock coming off of that pin before I put it back in the socket, and then we'll see what else is going on. Yes, we are. Yes, we are. That was the problem, at least with this, is that LS04. Good. All right. Let's put that pin back in its socket and see if the board boots up. Okay, well, just on the off chance that that LS04, 74 LS04 was the only problem, I went ahead and hooked everything up. I'm so optimistic. Oh, I forgot to put the pin back in. Hooked everything up and left that pin out. That would have been embarrassing. Okay, that's better. I don't have any of the other boards in, and I don't remember what the dip switches were set for, so let's just go ahead and turn it on, see if we get anything. Yes. Yes, immediately, Rudd's diagnostic. That is awesome. Well, so maybe that was the only problem. The nice thing here, though, is it'll go in and it'll check all of the other things. So right now, it's telling me that the 8253 timer channel has failed. So, I mean, that's kind of a deal breaker right there. So we know that that's not good. And I don't know what's going on with the text here. The text is not good. Is that an RGB to HDMI thing? Okay, there we go. So yeah, critical error, diagnostics have stopped because the 8253 timer channels have failed. So more stuff going wrong, but hey, at least the diagnostics running. Wasn't doing that before. So that means that the CPU is actually running. So one problem fixed, more to go. Okay, well, as you can see, I am in the studio doing editing, and boy, this video is getting pretty long. So I'm going to go ahead and stop the video here. There's some really interesting repair work that's coming up in the next episode that I've started but haven't finished yet. So I want to save that for the next video, and we hopefully will get this 5160 up and running. Well, right now, that's not working. But we took a look at the actual computer. We took a look at all the cards, and you know, it's a pretty cool system. I want to test out some of those cards as well, because we didn't get to do that, and perhaps we'll repair that memory card. But right now, I've got to work my way through these pesky problems on this board. Probably the most difficult early PC board that I've worked on, where it just seems like it should work and it's not, and nothing is obvious. So stay tuned for that video coming up soon, and be sure to check out these videos over here on the side for more content, and be sure to like and subscribe. YouTube would really appreciate that, and I would too. So thanks for watching, thanks for all your support, and we'll see you next time. Bye-bye.
End of line.